Hello all, welcome to my channel. In one of my last videos, I had discussed different types of errors, different categories of errors that can come, and I had mentioned few memory linked errors, and I had cursorily gone through some of the places where a memory error can come at driver and executor level. Uh, in this video, we will see further how these memory errors are there and how we can handle those errors in Spark. So let's get started. So, uh, common memory related issues that happens in Spark are due to following due to these regions to like if we have very small number of partitions, we are doing a large broadcast, we are using UDFs, we have window function without a partition by statement, we have skew, we have large streaming states, so those also can cause memory linked errors. So let's see how what are the different memory linked errors which we can see. One is out of memory errors, which can happen both at executor level or driver level. Driver level happens as when we are doing some metadata operation where the metadata is very large. For example, let's say if we are doing a file listing, we are creating in-memory file index, and that time we can get an out of memory error. Let's say we are doing a large broadcast. Again, driver can get overwhelmed with that particular data. So it can give an out of memory error. Or let's say, we are fetching metadata from high meta store, and that that metadata that is returned to the driver is very large, and that also can cause the driver to go away to get into a state where it is not able to process that because of lack of memory. Then we have executor out of memory errors, which is generally related to which are generally related to skew or join or window operations that can cause an executor out of memory error. Then we have other set of errors which are linked to GC overhead. So GC overhead is something happens when the garbage collection activities are not they are spending too much time than doing the actual processing, so it can result in long pauses and slower application performance, and even might give an error saying that okay, GC overhead limit exceeded. We can also have Spark out of memory error because of spill. Uh, and that spill can happen because of hash relation or hash aggregate execution that we are doing. Let's say if we are while doing, if there is no space left on the device, the local directory, that might cause an error, which will say memory linked error. Or let's say if there is not enough memory present on the driver to build a hash map, that also can cause an out of memory error. We can have SDFS issues. And let's say if someone is calling a coalesce one and it has collecting data from multiple partitions and the partition size are big, so it can also cause an out of memory errors. Then we have heap space errors. So there are there are two types of heap, off heap and on heap in Java. So if the JVM heap space is not configured properly and tasks and data that is being processed is large, that can cause a heap space to be exhausted and leading to errors like Java lang out of memory error, and it will say Java heap space errors. And then we have office space, which is used means which is sitting outside of JVM. Can help with reducing the GC process, but improper configuration can still lead to off heap memory issues that we will see. Then we have memory leaks. Memory leak is an I will say is a code related issue. So it might happen that your application is doing something which is not which is generating memory objects at a higher frequency than it is being cleaned up. Which is not linked to GC, but it is linked to some other state that is causing that particular memory leak. And the memory leak can happen because of different regions, your code. It can happen because you have a lot of, let's say, uh, uh, let's say you are migrating from Scala 2.3, 2.11 to 2.12 or 2.12 to 2.13. There might be places where, let's say, mutable class has changed or something, some collection object has implementation has changed. So the earlier whatever was being used might not work with the newer Scala versions, and you might see a memory leak happening in there. And to avoid memory leaks, we have to follow the right code practices. And if we see any memory leaks happening, we can enable this extra Java options to do a heat dump and see what is causing the memory uh, leak. Then, if we have memory intensive transformations and actions, for example, collect is memory intensive, broadcast can be other example, or JSON flattening can be another uh, reason why suddenly explosion happens. For example, Cartesian join, then that can also cause explosion in the amount of data that is being present in the memory, and those things can cause out of memory errors. Let's say broadcast variables. So we have concept of broadcast variables as well as broadcast tables. So broadcast variables are something which reduce the data shuffling, which is but again, that broadcast variable does consume memory, because it is present in the memory, both on the executor as well as on the driver side. So broadcasting large data can consume excessive memory and memory pressure and can cause out of memory errors. Data skew is another area where due to which memory error can happen in Spark. How it will happen is that suddenly if you have keys, as means we know that okay, in Spark everything is processed based on partition. So if one partition has too many keys, so that particular executor will get overwhelmed with too much of data, and that might cause an out of memory error. Task deserialization is specifically linked to memory. So if we have a size of the serialized task exceeds the task available memory, then the deserialization error will happen, and it can often when the data is being this can happen when there is a shuffle or a place where data is being sent from one stage to another stage. To address this issue of task deserialization, we can look at Spark UI memory to monitor Spark UI to monitor the application's memory footprint. We can minimize shuffling, we have to handle skew and stuff like that. We can also profile and then find out what is causing the memory leaks. uh, there are certain configurations which are linked to memory tuning. For example, the Spark executor memory tells how much memory will be available for the executor. The same goes with driver memory. Memory fraction is the amount of memory which is used for execution memory. Then we have storage fraction, which is the amount of memory used for storage like cache and persist. And then we have an option of setting the off-heap memory. We have an option of setting the memory overhead that we can set. We have an option of setting extra Java options, which is for loading right classes, as well as to, let's say, if we want to enable debugging or you want to enable the right set of GC parameters, we can do that using extra Java options. We can do compression for the shuffle data that is happening, that will reduce the amount of data that is being sent across if we enable compression. And then the same compression can also be used for broadcasts. We can also do a checkpoint compression so that the checkpoint data is small in footprint. And we can enable adaptive optimization or adaptive query engine that will help us with dynamically fixing this skew issues or basically when we have a large partition, it can be broken down into smaller ones, or the smaller ones can be coalesced into bigger ones to make the partition works well with the amount of parallelism that we have. So these are certain uh, places where we can see Spark memory linked errors happening. And top strategies to avoid OM errors is to use disk persistence, prevent schema inference, use salting techniques like adding random keys so that the distribution gets randomized and keys land into different partitions rather than landing in the same partition. Also, we can do cleanup once we have used the cache data and those are no longer needed, we need to clean up that so that the memory is freed for some other objects. We can look at Spark UI to find out what is causing memory issues and then take action accordingly. So yeah, this was it for this blog. We have gone through some common memory linked errors. So if you like this video, do share it, support the channel, and have a nice day. Thank you.